Hello, and welcome to Med Evidence Articles, where we encourage community research and education with weekly articles. I'm your guest host, Chase Berger, and this week we're talking about breakthroughs in type 1 diabetes research, islet transplantations, and the evolving landscape of type 1 diabetes. Millions of people visit Yellowstone National Park each year to experience the great outdoors. The hot springs, canyons, waterfalls, and geysers are home to a diverse ecosystem of flora and fauna. But for 66 years, something was missing from this picture: wolves. Their absence was a direct result of large-scale predator hunting that began in the late 1800s. By 1926, the last wolf pack in Yellowstone had been killed. Similar to this historical eradication, the human immune system can attack and destroy insulin-producing beta cells in the pancreas, resulting in an absence of insulin production known as type 1 diabetes. The pancreas is an organ along the digestive tract that acts as a gland, secreting important substances. Insulin is a key hormone released by the pancreas, which regulates blood sugar levels. Blood sugar, also called blood glucose, is like the deer and elk in Yellowstone, important for the health of the ecosystem, but destructive if unmanaged. Without insulin, blood sugar can become dangerously high or low, which can result in long-term organ damage and failure. For example, the eyes, kidneys, nerves, blood vessels, and heart, or death. Around 2% of the pancreas is made of cell clusters called islets of Langerhans, which contains beta cells and are responsible for maintaining stable blood sugar levels. The islets are like wolf packs, containing a large number of insulin-releasing beta cells, individual wolves. In the estimated 2.1 million Americans diagnosed with type 1 diabetes, the immune system mistakenly attacks and destroys the beta cells in the islets, much like humans once hunted wolves, eliminating entire packs they perceived as dangerous. Without functioning islets, the pancreas isn't able to produce the required amount of insulin, leading to elevated blood sugar levels that can harm the body over time. This is similar to how the eradication of wolves in Yellowstone led to overpopulation of deer and changed Yellowstone's ecosystem. Researchers don't fully understand how type 1 diabetes develops, but it is widely believed to be influenced by environmental factors that trigger genetic risks in susceptible individuals. There is currently no cure for type 1 diabetes. Most patients rely on daily insulin injections for the rest of their lives. Whole pancreas transplants can restore normal blood sugar levels by replacing destroyed islets, but they are risky and an uncommon treatment option. As a result, clinical researchers are looking into a third option that avoids daily injection complications and surgical risks: allogeneic islet transplantation. Allogeneic refers to cells, tissues, or organs that are from another individual of the same species. The mechanics of allogeneic islet transplantation are similar to the reintroduction of wolves to Yellowstone. In both cases, the effort is to restore the population and environment. Islets with healthy beta cells are taken from a deceased organ donor and injected into the recipient without surgery. Blood transports the islets to the liver, where they make and release insulin into the body. This reintroduction of islets with functioning beta cells restores the body's ability to produce insulin and manage blood sugar levels. It can take months to years for the islets to fully integrate into the body. During this time, islets can be attacked by the immune system. Immunosuppressants are typically used to prevent islet rejection, and researchers are advancing the ways in which transplanted islets can be protected, including by a process called immunoisolation. One immunoisolation product currently being investigated is tegoprubart, a monoclonal antibody designed to protect insulin-producing islet cells by calming down or controlling how the immune system reacts to organ or cell transplants. Access to allogeneic islet transplantation is severely limited in the United States. This is in part due to regulatory distinction. Under the current Public Health Service Act, allogeneic islets, those from a donor, are considered biological drugs and human cell and tissue products. This means that therapy providers must submit a biologics license application, BLA, to the FDA, which can be a lengthy process full of financial, legal, and logistical barriers. In November 2025, the Islet Act was reintroduced in the Senate to redefine human cadaveric islets, allogeneic islets, as organs, which supporters will believe will increase accessibility. In other countries, human islets are defined as tissues for transplantation, and allogeneic islet transplantation has become a standard of care option. In the United States, on the other hand, the small number of allogeneic islet transplantations were entirely conducted during clinical trials. Clinical trials continue to show promise for allogeneic islet transplantation, including new trials studying investigational immunoisolation medications. If the Islet Act and clinical trials both prove successful, we may have a new way to take a bite out of type 1 diabetes.
Thanks for joining us on this week's episode of Med Evidence Articles. If you'd like to know more, all of our sources are linked in the podcast description. You can also visit our website at medevidence.com and check out the Med Evidence podcast for discussions between physicians and subject matter experts. MedEvidence provides evidence-based information that empowers individuals to make informed health decisions. The organization stands apart in the presentation of unbiased clinical research in clear, accessible formats guided by medical experts. MedEvidence provides education for patients and healthcare professionals with a focus on research as a care option. Note that information provided in this podcast is for general educational, scientific, and informational purposes only and is not intended as and should not be treated as medical or other professional advice for any particular individual or individuals. If you are experiencing any medical issue or have any medical concerns, you should consult with a doctor or other medical professional. My name is Benton, and we'll catch you next week.